Welcome viewers welcome to Learning with Kamal. In today's session we'll be covering feature engineering and what are the different things that are done and what does feature engineering contains, or what are the different kind of activities which are done and how useful it is to us in the process of training your model and machine learning. Yeah. So today the topics that we'll be covering are what is feature engineering, how it helps us, and we'll do a code walkthrough using Titanic dataset. While doing the code walkthrough and during this session, what we'll be doing is defining the goal or our target of the model creation, analyzing the data content, identifying the data that relates to the end goal, and then we do data wrangling and pre-processing of the Titanic dataset to achieve our end goal or to train the model to meet the end goal. Yep, so that is what we'll be covering today. Now, what is feature engineering? So feature engineering is a process of identifying the end goal or the target of the experiment. So any modeling or any model creation is made for achieving a specific purpose, an end goal, a target, or a y variable which we say, or a dependent variable which we try to derive out of a given set of data. How do we do that? We do that using applying domain knowledge and understanding the data available for experiment. Then next what we need to do is do the pre-processing the available data, because often the data which we have is not clean, or it might have some what can I say, some error data, some out of range data, some null values, yeah, or the distribution of data is uneven. So we need to take a look at all those data which is available for our experiment and do a set of pre-processing so that we can build a model which can achieve the goal which we are targeting. So analyzing the data to realize impact correlation of each feature on the target end goal. So we also need to analyze the data and realize which features within that data are correlated to our end goal and what is the impact of those features on our end goal. Yeah. Then next what we do is add, remove, derive features from training data for modeling. So whatever data we have available for training our model, we look at it, we see if any additional features which are required, or if we can remove some features which we find to be irrelevant, or we can derive new features out of the existing data and add to a data set. Yeah. Now, what is a feature? Like, feature is an independent variable. So in a data we have n number of columns which are independent in nature by themselves. And what is our end goal? End goal is a dependent variable which is derived out of a set of independent variables. Yep. So that is what is feature engineering about. And we said pre-processing, I just mentioned a couple of things which we do, but just to summarize those, what are the things that we do in feature engineering is to make the variable suitable for modeling. We do the transformation of variables, we scale the values of the variables, we do some scrubbing by dropping some columns or modifying some columns or adding some columns. Then we do label encoding, and we do one-hot encoding. Yeah. Now, how this helps? So it helps, this exercise of feature engineering helps us with identifying the relevant features within the dataset. It also helps us identifying the irrelevant features within the dataset. It helps us gauge the model accuracy using various subsets of features. It helps us analyze the data, realize the impact of each feature on the target end goal. So this is the most crucial one. Like, it helps us analyze the data and realize which feature has the impact on the end goal which we are trying to achieve. Okay. It also helps us optimize the model's performance using the given data set. Like our data set might contain a lot of text values in the variables, it might contain some repetitions. So once we do modification by doing label encoding, one-hot encoding, we convert those to numeric values, we try and replace the null values. So doing all this will help us improve the performance of our model using the given data set. Once we go through the code, walk through with this example, you will realize this better. Yep. Let's move on. So we'll be using the Titanic dataset for this exercise. And let's start. So first thing what we need to do is identify the end goal or the target of our exercise or an experiment, we can say. So in this case we are using the Titanic dataset, and our goal is to create a model which can predict whether a passenger will survive or not. So that is the statement, or that is the goal or target which we are trying to work towards. Yeah. And on a lighter note, the domain knowledge that we carry for this Titanic dataset is watch the Titanic movie couple of times over and over again, and you will get some points or some domain knowledge which you can use in here in doing our experiment with this dataset. Yep. Let's go ahead. Fine. So let's start with the pre-processing of it. So we start looking at that data, and we see like what are the fields that we have within the data, and what are the count of null values within each fields of our data set. Yeah. So this can be done simply by running this statement. We say Titanic df is the data frame in which we have loaded our Titanic data set, and we check the sum of nulls in each column. So sum dot is null and access is equal to 0, and it gives us the result which is shown in this table over here. So these are the column names, and these are the count of null values within those columns. Yeah. So we look at some of the columns which has high null values. So we see cabin has 687, lifeboat has 546, body has 804. So the value of like the column containing null value, the percentage of which is very high. So we decide, okay, we skip these values. So for cabin feature 687 out of 891 missing records, we can simply skip that feature. There is no null value in ticket feature, but ticket number hardly gives us anything to any correlation to derive whether the passenger will survive or not. So we can get rid of those features also. Yep. So that is how we do look at the data and derive our conclusions and see if we require those columns or not. We can drop those columns, and if we require those columns, what we do with those columns. Yeah. Let's move on. So these are the counts of the null values and count of null in each column of data set. Yeah. So this is what this table is indicating. Now let's move ahead. Now we look at feature which was embarked. So embarked has two null values in it. Rest all carries some value. So we need to replace those null values with some relevant values which we can derive. Now we look at the values in this column and replace the missing value with those values which occurs most number of times. Yeah. So we see what are the values which commonly occurs in that. So we run this code line to get the count of different values which we have within that column, and we see that Q, C, S are the three different values which occurs in embark. Yeah. So we see that S occurs most commonly or the most number of times within that column. So we replace those two null values with value of S, and then we do an label encoding of this embarked column, like S is equal to 0, C is equal to 1, and Q is equal to 2. Yeah. So this is how we have handled the embarked feature. Let's move on. So like I said, we'll replace the null values in embarked with value S, which has most occurrences. We have done that, and we move ahead. Now we look at the next feature, which is name. Now looking at that particular feature, we might think how name can be relevant in whether that passenger will survive or not. Yeah. But let's dwell further and we'll see is there any correlation or not, right? So we just look at what are the different values which occur in name, and we see that each name has a title. Yeah. So we run this code line and see what are the different titles which are there, and we see this list and the count of each title. Yeah. Okay. Now what we do is we group different titles according to their similarity and replace them. So we replace them all with Mr., Mrs., Miss, Master, and Rare. So this is the line of code which is done to do this replacement. And then what we do is we plot a graph to understand its relation to the passenger survival. and this is the graph which pops up. And looking at this graph, what we realize is Miss and Master have better chance of survival, because if you see this bar charts clearly indicate that the Miss and Master have a high chance of survival. Yeah. Now, does that remind you of some domain knowledge? Yeah, if you have been watching the movie, like I said, watch it over and over again, and you realize in the movie one of the crew shouts women and children only while loading the passengers into the lifeboats. Yeah, so we can derive like why this bar charts give a high count for this particular titles. Yeah, let's move on. Okay, now we look at the next features, which is SIBSP and PARH. Now these names are not very friendly for us to derive what those fields are. So what we do is we derive two new features out of it, and we name it like with parents and with siblings. So SIBSP is actually siblings, and PARCH is actually parent and children. So we derive new features with the friendly names with parents and with siblings. So we use this code to derive those two new features. Like if sibling is greater than 0, then we with sibling is equal to 1, else 0. And we say if PARCH is greater than 0, then with parent is equal to 1. And now what we do is we plot a graph to see, how that correlates to whether that passenger will survive or not. And this chart indicates that parent children have better chance of survival. Yeah, so definitely this feature has some connection to whether that passenger survives or not. Okay, let's move on to the next feature, which is age. Now in age feature, earlier we saw there are 177 missing values out of 891 total records which we have. So we figure out the relation of age with other features using a heat map. So heat map shows us how that feature relates to other features within the data set. So what we have done is we have taken a heat map with regards to age, sex, SIBSP, PARCH, PC class, embark, and we see how these features correlate to each other. Yeah, and this is the heat map which comes up when we execute this graph. So we find SIBSP, PARCH and P class are relevant to age. We derive it from the correlation number which we get out here. Yeah, so instead of filling those missing ages with a mean value, we should compare the ages of passengers with similar family sizes and classes. So we have written a piece of code which actually does that. So for each age we have written two functions, and if we see if there is any match in background, okay, then we put a mean value with that background. Otherwise we put in a general number. So if no background match is found with similarity in family sizes and classes, we fill the missing value with a random value between the mean value minus standard deviation and mean value plus standard deviation. So within that range we select any random number and we put if we don't find any matching background. That is how we fill the missing values of age. Now since we have taken care of most of the columns which we have been using so far, now to finally prepare a data set for training, what we do is we simply drop the columns which are not required, and our data set is ready with the relevant features which contains derived features, no null values, label encoded values, and ready for modeling. So that is the end state of feature engineering. Yeah, and the code in which we have done all this using Titanic dataset is available at this particular GitHub link. So we start with loading this data set within a data frame. So from the CSV file we load titanic_df, which is the data frame name which we are using for this. Yeah, and this is the statement which we run to figure out the null values within each column, the count of null values, and this is the output that we get. Yeah. Now first basic thing which you can do is we'll do a label encoding of sex. So sex has male and female values, so we just encode them to 1 and 0, so those values gets converted into a numerical value. So we do a label encoding of sex. This is the code snap for this doing this activity, and here we just do a view of df.head of first 5 rows and see the output. Yeah. So if you see, sex is replaced as 0 1 0 1 0 1. Yeah. This is the code snippet which has been mentioned in the slide for handling the embarked feature. Yeah. This is the code snippet for doing the analysis of feature name, how we do handle the Mr. and Mrs. and Master, and how we see its correlation to whether the passenger will survive or not. And this is the code snippet which we use for with focus on SIB-SP and parent-child relationship, and see how it is related to whether the passenger will survive or not. This is one thing which I have not mentioned in the slide, but I'll walk you through in the code. So in our features list we have something called fair, and if we have any such value within your data set which you want to consider, you look at the distribution of data, how is the distribution within your data set. Yeah, so this we can do by doing a disk plot, which we discuss when we discuss representation of data. So, and we do a disk plot and see how the data is unevenly distributed. You see a big peak out here, then it just slopes down and flattens out eventually. Yeah. So to take care of this scaling, what we do is we can use logarithm to remove the impact of extreme values. This is the code snippet which actually does that. So we convert the fair to fair log, where we take a logarithmic of that particular value and use it. Yeah. So then we do a plot using the fair log, and we see, the distribution is bit improved compared to what it was earlier. Yeah. So that is one thing, that is what we term as scaling of values within your data set. Yeah. Okay. And this is the final data set which we prepared after we did all the feature engineering. Yeah. And we created X learning, we prepared our X learning and Y learning, and then we'll try to do a model fitment. Yeah. So we dropped all the unnecessary columns from our data set, and we just kept this. So we have our derived columns, we have our title which we derived from name, we have embarked feature, age, sex, and passenger class. So these are the columns which we have finally taken for deriving our model or for our modeling exercise. Now I've just briefly done and created a code to select a model and see its model's performance, and these are the values which this model has delivered, and we see that XGB has delivered 0.822, so that is we consider as the best performing model. But modeling we'll discuss in detail in our upcoming session, so I will not talk much about it out here. But just to give you an idea, like post we do the feature engineering, what is the data we extract from a given data set, and then we consume it for doing a modeling exercise. Okay. Thank you viewers, thanks for watching. Any queries, comments, please write into the comment section and I'll respond back to them. Once again, thank you very much for watching Learning with Kamal.